So do you wonder why you have lot of daemons in Linux? Whenever you see, so there are always either you call it as daemon or service. Do you know why you call it as a daemon? Anytime you have think about it. So why it called as a daemon? Okay. So let me, I will search it here. Okay. This format cells. So let it be. You have lot of. So you see here system D. Okay. Whatever it starts, it will be with the D. If it wents, it will be with the daemon here. Okay. I will make this as red color. Okay. And then. Okay. So this one also daemon. Okay. So this is all daemon. SSHD, HTTPD, named D, DHCPD, NTPD, all are daemons only. Okay. So why they are calling it as a daemon? It's a question for you. Okay. This is related to your topic only. Okay. Just think it, you will get the answer. So I will give 1 minute. Okay. I will pass this. I will resume the recording. So in Christianity, okay, you have something called angel and demon for everyone. Okay. Whoever it is, okay, you have angel and demon with you always. Okay. Let me get that one images. So angel and demon. Okay, they will always be with us. One will be serving good, and one will be asking for a let's say I will take this one. Okay, so what it will do? One will be telling good things and the other one will be telling the bad things. Okay. So angel will not be always with you. Okay. It will be like whenever you think good, then only it will come. So demon will be always with you. Consistently it will be with you. It will not leave. So that is the property of a demon. So it will serve you whatever you ask. It will not reject. So that is why they took the demon, okay, as a keyword, so that they will use the demon, okay, as a service. Instead of calling it as a service, we will make it like they are calling a demon here. So it is something like a dark theory also here, which is attached, okay. They started, whenever you want some service, you will be calling the daemon here. Okay, you see it. When the system itself is starting, you are telling it as a system D. Okay, this is system daemon. Instead of service, we are calling it as a daemon here. Okay, then startup D, upstart D. Okay, which is older now. Upstart D. Let me zoom this. Okay. Then you have SSH. It should be at least SSH, yes. Okay. So that it should be server or something like that. But it ended with daemon here. So all the major services are ending with the with the daemon service, where it will be running backend. It will not stop it. So it is going to serve you whenever you want it. Whether you require it now or you require it later, it will be running in the backend. Completely it will be running no matter whether you require it or not. That is called a daemon here. Okay. So VSFTBD, all are daemon services. Okay. So these are all these. For system service, you have COND, okay, ATPD. So few I have made it red. So I didn't have time here to make all this red. Some of them are doesn't have it. Okay. So this is the idea behind calling it as a daemon here. Okay. So I will in Linux I have made this complete document on it. Okay. Why you will be calling it as a daemon here. So you see it, I have made it as a devil also. So this symbol, if you see, this is the OS symbol. First OS created on Linux where they made it as a devil here. Okay. So this is a FreeBSD OS. So if you type FreeBSD, Free Berkeley Software, I will search it now here. Okay. So images. Okay. I will type FreeBSD. Okay. Free Berkeley Software Division. Okay. So you will get these daemon pictures here. Okay. So they started with a daemon symbol itself. This was the first OS they released it. So in 1950 or even earlier, okay, this was the first OS operating system which was released in open source. Okay. So now you will be calling this as a daemon, where it will be serving its purpose now. Okay. So this one will have a core properties. Whenever you start a service, so you will have a daemon here, so which will be serving you. Just like you have services, right, in Windows. So we have seen these services also. Okay. Services.msc. I am typing it here. Services.msc. Okay. So now I am running it. So here you are calling it as a properly, you are calling services, local services. These are all the services that I am running it here. My server is running. So in Windows, in Linux, what you are calling, all these running services in the background, you are calling it as a daemon here. Instead of service, you are just calling it as a daemon. Okay. One process will be handling lot of things here. Okay. So this is your system architecture. This is where once you start your system, okay, it will be managing all that services. So now dot service is a daemon. Okay. Whatever service start with dot service in the system D, it will be calling the specific daemon or specific process. So whenever your system will start in Linux, okay, all this will be managed in the backend. Okay, it will start whenever you start the service or you start Linux, Fedora or any OS, this is going to happen. Okay, so your daemons will get started in the background. Then your socket, okay, socket means connections. So whether you require a connection for that. So it will be on demand. So let's say you want to access internet or you want to access SSHD. Okay. So whether you want to connect it to the other server, all that, it will enable the connection to that particular service. That will be on demand. And there will be a timer here, it will be scheduled. Okay. So if it requires, okay, I am not going to start it now, I will start it later because my dependency services are not started. Let's say if you take the example of the kitchen here, okay, so until unless gas is not turned on, you won't light up the stove here, or you will not boil water or something like that. So this is completely dependent on the gas. So until unless you have gas here, you will not start the services which are dependent on this. Okay, so let me show you. You will have something called delayed, and you have trigger start here. In Windows, you see it here. You have delayed start. You see it is delayed start and trigger start. If it requires, then only it will start. This is not going to start immediately, okay, which is not required. So this is manual trigger. Let him trigger it, then only I will start. Okay. So this one, okay, this is delayed start. See, I am starting it. I will not rush it. Okay, I will start it as a scheduled start. You see all these delayed start, these are all automatic, but these are not started. Whenever it is required, then only it will start. So that is how your scheduled and delayed start will be. Okay. So then you are mounting all the file system, dot mount. So you have lot of hard disk. Okay, you have let's say you have attached 10 hard disks here in the system. Okay, so this got started. Now it started mounting your file system. So you have done this formatting, mounting, all that, right? So this will start once all these services and daemons get started here. Now the other units, it will start whenever it is required. So this is the whole concept of starting running services in the Linux operating system. Okay. So now this is all started now. So your first, if it is not running, what you will do, you will start that particular service. Okay, you will enable that service, then you will start that service. So SSHD, you will start once you are running. Okay, if you have any problem, then you will reload it. See, you will reload the configuration. Okay, or else you will stop that service. So these are all the services that you will be looking at for a particular service. So these are all the essential commands for the entire system control to that particular service. Okay, so you will enable it. So if you enable, then your SSHD will start at the boot time. Here itself it will start. If you enable it, SSHD here, system control, enable SSHD, it will start at boot time. If you are not enabling, then every time you have to start that service. Okay, so this is how your Linux OS will run. Okay, so the other one is you have a kernel operating system, kernel. Let me pull up this. Okay. So whenever you start it, you will have a kernel of that operating system. Okay. So with this, you will be using it, and you are calling all the files, input, output, all that, everything, it will be inside the kernel core services. So if you want any graphic driver, all that you will be asking the kernel, and your kernel will be providing this. This is how your Windows architecture will look like. So you have here device layer. If you want to talk to anything, so your OS kernel will speak with CPU, disk, network card, or any input devices. So this is how your operating system will be talking with the kernel and devices. Okay, even the Windows also will work like this only. So you will have here OS kernel. Okay, this is your kernel here. Let me. Okay, kernel means this is hard. Okay, so NTOS kernel, which will be abstracting all the hardware, and then you will be talking to that particular layer here. Okay, so all your devices, process, everything, it will be working in this way. Okay, so now uh, let me pass it. Let's say I have started recording. So this is your normal hardware. Okay. So so you are aware of this. Okay. So your hardware. Okay. This is your hardware. Let's say this is your laptop or desktop or server. You installed Windows 11. Then your app A is your what is that? MS Office. Okay. App B is your Python application. App C is your any third party application. This is how you are using. So what applications you have installed? Okay. So this is how your hardware, then your operating system, application A, B and C. Okay. So now after this you are using now virtual machines. Okay. So you have installed hardware, then on top of it you have installed the hypervisor here. Okay. So now what you are doing, instead of installing application, you are using the hypervisor and running VMs. Let me run one VM. Okay. So now I will start this VM. Now I am running a VM here. Okay. So let me connect it. Okay. This is where I am running a VM here, virtual machine. So you are also doing the same thing, right? You are running Fedora. So instead of Windows, you have created one more and then you are running. So I have done multiple installation here for VMs. Now I am running it multiple VMs here. Okay. Start it. Okay. So I have OS here. Then I am running multiple OS here. So you have one OS and the second one. So like this I am running lot of operating systems on my computer. Okay. So now I will come back to this here, our topic. Okay. So instead of using one operating system, see I have installed a layer and then I am using the guest OS, here Windows, then here Fedora, then here Ubuntu. I am using multiple OS and then I have installed applications on it. Okay, in the Fedora I have installed HTTPS and then SSHD. I am running other applications also, Nginx. All that I am running it on one guest OS. Okay. This is the concept of virtualization, VMware. Okay. So now what I am doing, okay. So I don't want to install the complete operating system here. So it is very heavy for me. What I am going to do, I will install a Docker engine, okay, or a container hypervisor. So I will just use this guest OS. Instead of putting 1, 2, 3 here, what I will do, I will take the guest operating system and then I will run the separate containerization here, so that I don't have to install one more hypervisor. I will be using this guest OS itself. So where I will be isolating it in the container. Okay. So now we will go with one more example here. Okay. So let me take one example. So now you are sitting in an exam hall. Okay. So you have let me get the paint here. I will get one paint. See here you have let's have three exam hall. Okay, it is a you entered into a college. Okay, you are writing your NEET exam or some other entrance exam you are writing. Okay, so what you are doing it. So you have it's not working. I'm just checking why the pointer is not working. Yeah. So now you have sitting in one hall. Okay. Two. So you have four exam halls here. Okay. So the college management decided, okay, instead of putting all these four exam halls, okay, what we will do, we will put it in a auditorium here, okay. Let them write it in auditorium, okay. So we will have only one invigilator monitoring it. So let's say this is your VM1, this is VM2, and this is VM3, this is VM4. Okay. So instead of all these VMs, so you are clubbing one, okay. One invigilator will be managing the all year, okay, all these days. So this is what a container will look like, okay. So in VM, you are virtualizing the hardware here. So you are taking the hardware and you are virtualizing the hardware. So in container, you are virtualizing the OS here. So you will be running this service, okay. Let's say, I will take one more example here. Let's say you want to do some work, okay, or you want to interact with one process. Let me take it something here, green, okay. So you want to do some calculation. Let's say you want to do some calculations, okay. So you are calling one process here. Process one will do the calculation, or you are using a calculator app, okay, which will call a OS kernel. Okay. So here you will have your OS kernel and this is your operating system. Okay. So then you have here hypervisor. Okay. So then you have here hardware. Is this clear? Let's say you want to run a calculator here. Let me open a calculator here. I will type run. Okay. I will type calc. So you got a calculator here now here. Okay. So my calculator, this is working like this. So you have calculator. So this calculator, okay, it is asking, it is completely coming up, it is interacting with OS kernel, and then OS kernel, this is the operating system. So then I am getting it from hypervisor, then with the hardware, okay. So let's say I am one more user here. So this is user 1. This is user 1, okay. So user 2 is running, okay. So now this is the same OS, okay, this is all the VM. In one VM you are doing all this, okay. Let's say you are extending this operating system. This is a VM only, okay. So this is, let's say this is your virtual machine. Okay. So one more user logged in and he is also interacting. Okay. He also got the calculator. So all the application users are interacting with OS kernel only here. Okay. So now instead of getting it as a VM, VM1, okay, let's say you have one more operating system here. This is VM2, okay, and then you have OS kernel here. Okay. Then this guy is also having a looking for calculator. So what this guy will be doing, again this is your hypervisor. Okay, this is your hypervisor layer. So you have VM1, this is VM2, and this is one more you have VM3 here. Okay. So let's say you have VM3 here. Okay. So whenever you want, this is operating system and this is OS kernel. And then you are asking for calculator. This is how it is going. Okay, I will take the red here. So whenever somebody is asking for calculator, this will go to OS kernel, then your operating system. This is where the your piece of code is. Okay, your application is. Okay. So now what they have thought is, okay, why you need an operating system everywhere here? Why can't we do it completely a operating system for common for every user? Instead of creating VM1, VM2, VM3. So anyways you have here in the operating system, they are calling it the application only. Why can't we have only one operating system and serve the purpose? So we'll go to the graphical here in this. Okay. So now let's see how this architecture will look like. Okay. So now you see it here. So this is your hardware. Okay. So there is no virtualization. Directly you are running operating system. And then you are running your applications here, your MS Office, your Brave, Chrome, Edge, all you are running. This is your physical, no virtualization. Now you are running it on a virtual box. So where you are running Ubuntu, or you are running Windows, or you are running Fedora here. Okay. So you have installed everything. Guest operating system here. Okay. All operating system you have installed. Now I don't want this. I just want one Fedora here. Okay. Or I will be using my underlying operating system. Okay. Let's say I have installed Windows or Linux. Okay. So what I will just do, I will just install the Docker engine here. Whenever somebody asks, I will just give it here. Okay. So I will give you the example here. Okay. I will take it, this one. Okay. I will cut it and we will go back into Paint now. Okay. So let's take this one. Okay. So we will go back to this. So in hypervisor, okay, let's say this is your calculator. Let's say you will go with our example only. So here you have, this is your, this is not your Ubuntu. Let's say this is your Windows 11. Okay. This one is also your Windows 11, and this one is also your Windows 11. Okay. So VM, this is VM 10. Okay. This guy wants calculator. Okay. VM2 also wants a calculator. Okay. So VM1 also wants a calculator. So you have complete OS here. Okay. You have complete OS here. You have complete OS here. Okay. So you are calling the application like this. Okay. So you had a concept now. Okay. Why can't we have a single operating system instead of 1, 2 and 3 instances? Why don't we put it the entire operating system here itself? Okay. OS, and then we serve it for user 1, user 2 and then user 3. So that is where the concept of containerization came. Okay. So I will have my base OS. Okay. So now I will virtualize this with the container. Okay. You want calculator, right? Okay. So you just take it from me. I will give you. Okay. So now user B or application wants to use my same application. Let's say calculator only. I will give it for you. Okay. This is user 2. Okay. Now you are using user 3. Okay. You come and take from my OS. You don't go as a VM here. So you will have a huge footprint here. So I will be managing all that here. I will be separating you. Okay. So I will give you a security separate layer. You cannot see what user 1 is doing here, what user 2 is doing. I will give you a separate layer here. Okay. So all I will give you the access separately so that you will feel isolated. Means you will feel it. So I am the one who is only accessing. I have the exclusive access. This is what the containerization is. So you will be installing a Docker engine to virtualize your operating system. So here you are virtualizing your hardware here. You see? So you have virtualized the hardware layer. Here you have virtualized the OS layer. So that is the difference between virtualization and containerization. This is containerization. So you will be sharing your OS here. Here you will be sharing your hardware. So that is the difference here. So I will pass it now. So now here let's do a cross comparison between all the layers here. Okay. So physically you are doing everything on the physical part. Okay. You are not doing any virtualization, nothing. Okay. Everything on the same OS, you will not have any isolation. Okay. So everything will be running on the your physical layer. Okay. If you start, it will take 1 or 2 minutes. So once you start your laptop, it will take 3 or 4 minutes or 2 minutes to start. Okay. This will be your physical, where you have performance 100% native to your physical hardware. Okay. So now you have installed a Fedora VM. Okay. You have installed a Fedora VM. Okay. So now what you are doing? So you are using it. Separate storage you are using. So you have assigned the disk here. Okay. So then you have a separate layer, your hypervisor layer. Okay. So you are virtualizing the hardware and you are booting it and you are powering on. Okay. So you have complete OS included. So you are not sharing your OS, right? Yeah, Nilanchan or others, you just speak. So you are not sharing your OS here. You are installing everything on a virtual machine. You are telling, see, I don't care, I will not share anything. You get all the information from the VM only. Okay, you take this, you install the Ubuntu, you take everything from this guest OS. I am not going to give anything here. Okay, this is how your VMs will work. It will have a complete strong boundary. Okay, if you are doing it something on that VM, it will be dedicated to only that particular VM. You cannot share it to the other VM. Okay, it will have all its binaries, executable files, everything will be lying here in your VMDK file. So whatever you created, it will be copied in your VMDK file. It will not get stored here. Okay, on your hypervisor layer here. Okay. So you will be having a strict OS type and it will have a strong boundary. Okay. So now let me show you the hypervisors here. Okay. See, I am running Linux here. Okay, this is my Fedora. Okay, I have 3 users here which are completely isolated. This is the Fedora OS. So I am on the Windows OS. So my host OS is Windows. You see, this is my Windows. Okay. So I am running the hypervisor, Hyper-V. I am running here multiple VMs here. So this will be completely dedicated here. So I don't care what exactly this is going to run. So now I have one more OS here. Yesterday only I installed. This is Cache OS. Okay. So I will open up now. Okay. I will put the password. So it will look similarly like Windows, but it is not Windows. So this is number one OS being used in the open source market now. Cache OS is the number one OS now exactly running on the internet now on most of the desktops. Okay. So this is completely running isolated. So there is nothing to do with my operating system. It is running individually. You see it here. So this one is running separately and this is running separately. Okay. So let's say I want to run Windows 10. This is my Windows 2019 server. Okay. I want to start Windows 10 here. Okay. Let me start it. So now I am running Windows 10. This is having a database, that is why it is starting very slow. Okay. This is my Windows 10, which is client OS. So now I am running 3 operating system here on my computer, which is Windows 2019. Okay, which cannot run like this. So I am running it in a completely isolated environment. Okay. Now we will go back here to our topic. Okay. So now you see it here, my VMs are completely isolated and they are working independently here. They are not dependent on my hypervisor here. So they got their own OS and they are running it here. Okay. So now in containerization, what I am doing, I will install the Docker engine here. Okay. Once I install the Docker engine, they will start using my host operating system here. Whereas in VMs, they will run independently. Okay. So in Docker engine, they will be bound to my operating system. So they will not have their own operating system. They will be sharing my OS or my kernel. They will be sharing it. This is what Docker engine will do. Okay. So here you will be calling it as a container here. So you install MS Office here. you install MS Office one more time or any application here. Okay, so all they are coming here in your operating system and they are pulling the data. So they don't have any VM here. Okay, so your operating system, you are sharing it. Okay, so this is how you will be doing the containers here. So if you see it here, your boot time, if you are starting it, any container, it will take only millisecond, because you are sharing your existing operating system. That is why it will take only few milliseconds to start. Okay, so now what you are doing is you are virtualizing the operating system here, not the hardware. So wherever you run it on top of that you will be virtualizing. So you are virtualizing the hardware here. That is why you are creating the multiple operating system here. Okay. If I install Docker engine here, then I will be using my Windows 2019 only, not any other application. I cannot run it. So for time being, you understand it like that. Okay, so I will be sharing my Windows Server 2019 with any application. Okay, so here you are isolating it. Okay, so your performance will be very low. So your overhead will be very low. Okay, so you are installing a hypervisor layer here. So here you are not installing any hypervisor, you are directly interacting it. So that is what we call it as overhead. Overhead means it has to interact with hypervisor, then with the hardware. The response time, whatever you get to reach it here, that is called overhead. So your performance. Okay. So when you have installed your operating system, there is no layer in between your host operating system and your hardware. You will directly interacting with the hardware here. So here you have kept one more layer, then it has to pass that. That is called overhead. So now your storage size, okay. So storage size for each and every VM, you need to have at least 4 GB to 10 GB. All files you need to install it here. So here you don't need the complete OS here, only few MBs are required. So let's say you want to install one application, one container, okay. So you will just install it and you will just start using it. So you are not installing any OS here, you are just installing one application here. That is why it will require only MBs and the application. Okay. So here you are having a strong boundary at the OS level. Okay. So you are running it at the process level. So your kernel OS is shared, okay. Only the process you are dealing, you are just separating it. So let me take one break, okay. So now I will take one more example here. Let's say it is not clear for you, I understand it. Okay. Let me take one more example. So you have one apartment here, okay. See, this is one apartment and there is one hospital here, okay. So I will take two examples here. Same, our example is has not changed. It is same, okay. So what you are having it here, okay, let's say, so your green color is your hospital, okay. So this is a hospital here, okay. So green color, it is a hospital, okay. So here your blue color, this is a apartment here, okay. So in apartment you have, let's say you have 20 individual house. Okay. So I will create it like, okay, you have 20 individual house. Okay. So each will have its own kitchen here. So they will be creating it their own kitchen, and they will be serving inside their family. Okay. So let's say you have 20. Okay. This is individual house. Okay. Let's say you have you are serving 50 people here total. Okay. 20 house. So now you have it. This is a hospital. I will change the color now. Okay. This is a general ward. Okay. General ward. Okay. Not a special ward or semi or private ward. Okay. This is general ward. So in general ward you are having 20 beds here. 1, 2, 3. Like this you have 20 beds. Okay. So here you have individual kitchen, and they are preparing by themselves, and they are completely isolated and independent. They are not dependent on it. Okay. So now here in your general ward, okay, all the food is supplied by the hospital. You cannot take any food from outside. Okay. They are serving the food for 40 patients in one ward. This is general ward. Okay. So here you are using the entire apartment here. Let's say this is a 20 means it's 8-story building. Okay. This is a single floor. One single floor. Okay. This is 8-story building. Okay. 8 into, let's say this is 3. Okay. You have 3 into 2 BHK. Okay. Each floor is having 3 2 BHK house. Okay. Here you have just one. This is a size of 2 BHK house or 3 BHK house. So all 40 patients are lying in general ward, and you are serving the food here. Okay. You are creating it from one single location at one single place, and you are serving it to all the patients here. Okay. So if you take the example of this will be the containerization here. Okay. So everything is being cooked in one single kitchen. Okay. There is no individual or separate kitchen for all these guys. So they have to share it, the single kitchen. Here in virtualization, okay, so you have individual kitchen. So everyone is isolated. They have their own operating system. They have their own OS kernel, process, everything. You are completely in isolated environment, and you have your own OS. So here you don't have a OS here. You are sharing the OS here. Whatever you have it, everyone is sharing the OS here. So in individual apartment, you are having a complete OS here. Okay. So you have your own. Okay. Let's say you have here your 2 BHK means you have 2 bathrooms. Okay. So here you have only 5 bathrooms. All are shared. So this is completely individual. Nobody is sharing it here. I hope you don't have any Sulabh complex in apartments, right? So you will not have any Sulabh complex. It will be completely independent. Okay. Here you will have a shared. Okay. You have 5 bathrooms. Sometimes you may be having 3 bathrooms only. Okay. Or washrooms you can call. So this is your containerization. This is your virtualization. So every house, every OS will have its own capabilities to distinguish between the other house or other VM. So I am not dependent on you, you don't depend on me. Okay, this is vice versa here. Okay, so I will take it. Okay, let's see this one as a virtualization. And now this is the containerization. That is why it is very lightweight. Okay, and this will be heavy because you are running all the OSs here. So you are running 20 operating system here. So you are running only single operating system here. Okay. So that is how you will distinguish between virtualization and containerization. So most of your workloads will be on your containers, not on the VMs, because you will be using it the complete OS. You don't want to use a heavy VM. Okay, most of your CI/CD pipeline or your DEvops work, 70% you will be running in containers only. Okay, your 70% whatever you run, it will be on containers. Okay, 30% it will be on VMs. Okay, now you tell me how much you understood. Is it 55, 60? Go through the documentation here. Okay, so whenever you are running a container, okay, so this is your virtual machine. Okay, so in virtual machine you will install a hypervisor. Okay, you have hypervisor here. Okay, so let's say this is your virtual box. Then you install VMs on top of your hypervisor, VM1, VM2, VM3. Okay, so you will install the complete OS here. Okay, so you are completely having a operating system, and it is not going to share your OS, but it will share your hardware. So VM will take your hardware. It will not take your OS. Perfect. Let's say I will open up my hypervisor here. Let me open up. Okay. You see, it is taking my hardware. Okay. This is consuming 3.5 GB, 3 GB and 3 GB. Okay. My VMs are occupying my space here. Okay. So I will show my task manager here. You see, out of 24 GB, 21 GB I am consuming. Okay, my VMs are taking up. Okay, let's say these are taking 11 GB here. Okay, they are using my hardware. They are not using my software or operating system. They are just consuming my physical resources. So I will come back here. You see now. Okay. So they are using my hardware here. The hypervisor, okay, your virtual box is giving the hardware for lease here. Okay, you use it until you power off. So you take this. Okay, this is how your VMs will be working. Okay, which will be heavier. So overall a VM will be heavy. Okay, this is how your application will be running like this. So you have libraries, binaries, tools, and then your NTOS kernel, everything you will be having your own individual. Let's say this is your kitchen, your individual. This is your toilet, bathroom, kitchen, all that you have 2 BHK here. Okay. So this is one 2 BHK, this is one 2 BHK. Okay. This is your apartment. Okay, so this is your apartment, infrastructure is your apartment. Okay, hypervisor is you are dividing the apartment into individual houses. So now here what you are doing it here, this is your hospital. Okay, host operating system is the single room for the general ward. Okay, this is a general ward. If you take the example of general ward, okay, so there is no individual kitchen here. So there is no OS. You see it, you are having a operating system on top of the hypervisor here, but whereas in containers, you are running everything on the operating system itself. Okay, so this you have taken one 2 BHK room. This is a individual 2 BHK room. Okay, so now you have created beds here. 1, bed 2, bed 3, like that you keep on going like this. Okay, so this is your container engine which will share your operating system. So I am going to take, okay, anyways from here you are taking it from the operating system. Here you are taking directly from the host operating system. So that is the difference. Okay, so we will take one more few examples also here. Okay, so let's say you are running it. Okay, this is your full VM, this is your virtual machine. Okay, so here this is your host operator, this is your container. Okay, on container you are running a application 1, 2 and 3 directly on the application, directly on the OS part. So this will be looking like your guest OS. Okay, you have full VM here, you installed it on the hardware. This is your hardware, whatever you are seeing it, this is your hardware. Let's say this is virtual machine and this is a physical box. So I don't need any VM here. Okay, I will just directly run it on a container. Okay, so I will put it a container instead of installing virtual box. I will install a container software. Once I install container, I will directly share it with the applications. I don't need OS now. So here you required a complete OS to understand it. So once we run it, you will come to know what is the difference. We will install one Docker engine, then we'll run the applications, we'll see that difference there. Okay, so now you see it, the difference between container and virtual machine. So in virtual machine you have server hardware, your host operating system, your Windows 11, then your hypervisor, what you are using, VMware Workstation or virtual box. You install it, then after that what you are going to do, you are doing it, this is the complete guest operating system. Okay, so on top of it you are installing the application inside a guest operating system. This is how it will look like on a virtual machine. Whereas in container you are just using the operating system. You have just put a container software. Okay, I will call this right now as a software, I will not call it as runtime. So this will give you that layer so that you can directly talk to the operating system. You don't need a hypervisor. So it will remove hypervisor and it will take over. Okay, I will give you isolation. Okay, you just let me know what application you want. Okay, this is how it will look like. Okay, so we'll install one Docker. Okay, so we will run it, then you will come to know the difference between the Docker and your virtualization software. Okay, so anyways I will share this. Okay, I will share this content. I have just created this, I just updated all this with the images. Okay, so once we will see this is how layer by layer work. Okay, so this is your physical layer. Okay, and then you will have your host OS. Let's say this is on your Windows. okay, instead of installing virtualization software, so you will install the Docker engine here. Okay, so where it will run the Docker daemon here. So now you correlate why I asked you to know about the daemons here. Okay, this it will be running the process daemon. Okay, Docker daemon. It will be interacting directly with the operating system. Okay, then it will be giving you all the required applications here. So it will create separate networking here, just like how you have done the networking, NAT networking, bridge networking, host only networking. Like that, this will isolate the users here at the OS level. Okay, so this is how it will look like. You are running everything on one container. Okay, like container A, container B, and container C. This is database, this is application, and this is API. You are running single all these containers in one Docker engine. Okay, so what we will do, we will install it. We will install a Docker engine. Okay, so then we will see the difference between VirtualBox and Docker engine. Side by side we can see. Okay, then you will come to know. This is just the theory part. So once you do the installation, so I want you to do directly on your laptop. So you don't use any virtualization software, so that it will be directly you can understand the concept better. Okay, so what we will do on today is Tuesday, right? So Thursday we will do this practical. Okay, on the on your laptop directly you will install Docker engine, and then we'll start your containers. Okay, so I will stop recording now.